Did we get to this problem yesterday? If we did it, like in some classes I got to this one, but I rushed through it, so I will start again.
We did.
I for some classes got to this one, and this was their last one. Some classes weren't, so I don't remember exactly how it was in this class. I think we got to it, but even if I did, I went through the class. But I just want to go over it one more time. Huh? So I just want to go over it one more time. Okay. I want to make sure you know how to use your calculator. So, Mr. Romero, I know that, but we're not going to use the calculator on the test. So, okay, that's fine, but we're going to start transitioning to calculator. So, I want to make sure you know how to find all the keys on the calculator. So, negative 32 to the 4th power. Every problem that's left on the notes fell under the directions of simplify. We're trying to simplify. And if you are trying to simplify, something here should grab your attention before anything else. The what? Now the only reason the parentheses really it even has to be there is because of the negative. Because you're not actually doing anything in the parentheses. The exponents of fraction. Yeah. There has to be a way to remove that. In this particular case, that base of negative 32 actually fits right in with that particular fraction, meaning if you were to put that in your calculator, yes, you would get a whole number. You would get an integer. There would be no decimals. But what happens if the calculator wouldn't work? That's the approach I want to take. At the end, we're going to end up using the calculator, but I want to show you what you would do if it didn't work. First thing I would do, what can I rewrite any rational exponent as? Somebody who learned something yesterday.
A radical.
Very good. The type of radical depends on the denominator. The denominator here is 5, so what type of a radical would I write?
With an index of 5?
It's called the 5th root, yes. And the 4 stays with the negative 32. Do I expect you to know that negative 32 to the 4th power is 1,048,576? No. Not without a calculator. But here's what theoretically you should be able to do without a calculator. Because let's say you did it. You're not going to have anything this big without a calculator, but let's say that here's what you could do. Everybody here should know what happens when you take a negative number to an even power. It becomes positive. So you should, without a calculator, you should know no more negative. Negative 5. Okay. The other thing you could do, since a power just means multiplying times itself that many times, this is the same thing as saying 32 times 32 times 32 times 32. It's 4. And since you're used to writing numbers as a product underneath a radical, maybe you can't do a tree with a number this big. I could. It would take a while, but I could do it. But maybe you wouldn't want to. But you could do a tree with a 32. To save you the time, I'll tell you, a tree with 32 is 5 2s. If you did a factor tree with 32, it would be 5 2s. And if this 4 just means, well, there's 4 of those trees. 5, 5, 5, 5. In reality, how many 2s would be underneath that radical? 20. Now, what would be slightly different, but you could use some context to try to figure out, if on a square root, I need 2 of every number in order to jump out, how many groups of what do you think you would need? 5. Yeah, you need 5 for a 5th root. So if I were to write down 22s underneath the square root, and I needed groups of 5, if Julius and 19 of his buddies go to play basketball and they want to get in teams of 5, how many teams can they make? 4. They can make 4 teams. 19 of his friends.
Also, Julius.
So now in this case, it wouldn't be 4 Juliuses; it would be 4 groups of 2s. So you bring out 4 2s, and what's 2 times 2 times 2 times 2? It is 60. Okay. But now let's practice using our calculator, because that's kind of what I wanted to get at. Every calculator, even if it's not scientific, has a square root, but we're not using square roots. Very few calculators have a button dedicated just to a cube root, but some do. Every scientific calculator, not every calculator, but every scientific calculator has a root key, and for any root that's above a 3, that's what you would have to use. So that's your little goal right now. You need to figure out where to find this button on your calculator. You might have to hit like a math button. There might be a button that says math on it. And then you have to tell your calculator that you want a fifth root by hitting a 5 before. Julius, on your calculator, if you only have a single line display, you have to actually hit the 5 after. You have to put the big number first, then the root button, and then the 5. So the little exercise now is to see that same 16 that we said that we were going to get, see if we can get it on the calculator. And if you can't, let me know. Now come and save the day.
You said it should say math?
Some calculators, if you don't see a root button on the actual face of the calculator, you might have to hit like a math menu. If you have the same one, yeah, it's there. It's on the left side, right above the exponent button. Yeah. So you would do 5, then that second that, and then the big number. You would get 5 first. 5. Then second, you will exponent. So you did second first. And now type in the big number. Brad, Pat, you okay? Hang in there, buddy. Rad, Pat, and sad, man. But by the end of class, we'll be glad.
You should be alright. It don't look like he's like math. I feel like his next time.
Okay. Any questions? Cloud sound. Okay. Okay, here's another one. Still follows under the directions of simplify. That says 16y to the negative 8 inside the parentheses. On the outside it says to the power of negative 3 over 4. Because there's multiple operations, there's a little bit of flexibility as to what order you do this in. So just because I do it one way doesn't mean that it's more right than something else. Since you are simplifying, what is gaining your attention? The exponent's a fraction. The exponent's negative. I have 2 negative exponents. And now in this case, Elizabeth, the parentheses is gaining a little bit more of my attention because on the inside, it's not just one number. I have a 16 and a y to the negative 8. So all of those things need my attention. The parentheses I need to get rid of. The negative exponent I need to get rid of. The fraction I need to get rid of. In this case, actually, I'm going to choose the parentheses first. You could deal with the negatives, but I think that would be more confusing to teach that way. And when it comes to a negative and a fraction, you always got to do the negative first. So the fraction is going to have to wait. So what I'm going to use are those properties of exponents that we went over yesterday and you just studied over and over and over and over again to memorize them. One of those properties says that when you have a power on the outside of a parentheses and I'm multiplying on the inside, what am I allowed to do? No.
Distribute.
I'm allowed to distribute. So I can take that negative 3/4 power to each term. Now, when I take it to each term, see, yeah, the 16 is just going to get the negative 3 to the 4, but that y already had a power. So what did we learn happens when you have power of a power? What do you like to do with those powers? Not add. Multiply. Good. What is negative times negative? Positive. 8 times 3 is 24. Divided by 4 is 6. By distributing, that allowed me to get rid of the negative. It allowed me to get rid of the fraction, which is why you see a box around the 16 to the negative 3/4 because now that has all my attention. I don't have to worry about the y to the 6. y to the 6 is going to stay as is. Got rid of the parentheses. Elizabeth, that's... You okay? That's like scared face.
No, I need to sneeze.
You need to sneeze though. Does anybody not know how I got the 6? So I can just forget about that for now. Because I'm going to move my focus to where the box is. This says 16 to the negative 3/4 and then y to the 6. But the y is now being taken to a positive power, there's no more fraction. Okay, so the only thing left is the negative on the 3/4 and then the 3/4 itself. And I just said about 30 seconds ago, when you have a negative and a fraction, which one of the two do you have to deal with first? The negative. Yeah. How do we deal with a negative? Who remembers from yesterday how you deal with a negative exponent? Cody? Well, you don't necessarily need to always put a 1. You only put a 1 if there's nothing else there. Because in this case, since I already have a y to the 6, okay, since the entire expression is not being written as a fraction. I realize you see a fraction in the exponent, but you don't see a big fraction bar. So now what I'm going to do is drop that 16 to the bottom, and I can make the 3/4 positive. So now the only thing I have left to do is deal with the fraction. How can I simplify a rational exponent? Somebody not named Lorna, tell me what I can do to simplify a rational exponent. Mimi, you know?
No.
Change it to a radical. What type of radical would this be? 4th root, very good. Of 16 to the 3rd power, but Mr. Romero, we're not going to have a calculator. How am I supposed to know what 16 to the 3rd power is? Well, you won't get a number that big, but you could theoretically still do it by doing a tree with a 16 and then just putting 3 of them. A tree with 16 is 4 twos. And you would just do 3 of them.
That would be 12.
It would be 12 twos. And to jump out of this radical?
It would be 6.
4. You would need 4 to get out. Groups of 4. You would need groups of 4. But I'm not even gonna get into rationalizing because you don't know how to rationalize 4th roots. You're not gonna be expected to know how to do that. What I would rather focus on is let's say that we did have a calculator because this is gonna work out very calculator friendly. 16 to the 3rd power is 4096. So on your calculator, you find your root button again and see if you can take the 4th root of 4096. Yes.
So would these be on the test?
What could potentially be on the test? You might have like negative exponents that you have to know how to simplify. You might have rational exponents that you have to change into a radical. But as far as computation without a calculator, having to take like 16 to the 3rd power, no. You won't have to do it. 4th roots, you're not gonna have to have a calculator. But you have to know the rules for exponents.
So on the test is also going to be square root.
It's gonna be mostly square roots, yeah. So did anybody find the root button? Tell me what the 4th root of 4096 is.
8.
What'd you guess, Suna? 8. And I agree with Suna. Yes, it is y to the 6th over 8. After the first step, nothing happened to the y to the 6th. Any questions? Okay, last example, and then anytime after that, I'll just use it to do some problems with Khan Academy. No? Do you want me to leave it on the board? You guys don't want me to do the last one? So I need to go back? No other questions here?
Oh, I got a question.
Yeah.
How can you didn't do nothing to y.
How come what?
You didn't do nothing to y.
Does it have a negative power?
No.
Does it have a zero power?
No.
Does it have a fractional power? So there's nothing I can do. Are there any other y's? If there would be other y's, I could maybe add the exponents or subtract the exponents, but there's no other y's. So there's nothing I can do to this. Okay, last one that's from this slide, from this presentation. Lots of different operations here also, just like on the last one. There might be more than one way to get to where I'm going to get to. What I care more about is that we understand what needs to be quote unquote fixed. What do I need to simplify? I see a parentheses. This parentheses being more important than the very first one we saw because again we have an operation on the inside. Unlike the last one, we're not multiplying here. What are we doing? We're dividing, but there is an exponent on the outside and division on the inside. That's something that we can tend to. Each term happens to have a fraction as an exponent, and not only a fraction, it has a negative. Now, because those are negative fractions, if I chose to start off simplifying those, I'd have to deal with a negative aspect of it first, which is what Cody said would be, I would have to flip them. If I wanted to start there, I'd have to bring the x down and bring the y up. And you could, there's nothing that says you can't. If I ever see a parentheses, I typically like to do that first. But it's not because it's better or not better, it's just out of habit. So when I have a power outside of a parentheses and I'm dividing on the inside, what am I allowed to do with that power? Distribute. Okay, distributing two numbers that already have powers. What are you going to do with power of a power? I'm gonna distribute this 15 to numbers that already have powers. David, can you see that? You can move closer if you want. There's an open seat here in front. You can always move up if you want if you can't see. It says x to the negative 2/3 over y to the negative 1/3, and then there's a 15 on the outside. How many of you already had these notes written because you went home and looked them up in class? So I'm going to multiply. Yeah, what is 2/3 of 15? 2 times 15 is? 30 divided by 3 is? 10. Since negative times positive is negative, I get a negative 10. On the bottom, 15 times 1 is? Divided by 3. But again, negative times positive is negative. So I get a negative. So I got lucky here because I got like a 2-for-1. I was able to kill 2 birds with 1 stone here. My intention was really to only get rid of the parentheses, but by getting rid of the parentheses and multiplying, that also took care of my fractions. So I only have one more aspect to deal with, and that's the negative. Now Claire just asked, well, hey, can I just subtract? Which I'm glad you're making the association of division and subtracting exponents, but here, why are you not allowed to subtract them? Different variables. Yeah, different variables. One's an x and one's a y. But what you can do is do what we did the last time. How do you fix a negative power? You flip it, flip the script. The x drops as if it was hot, and then the y goes up to the top. And then by flipping it, I can make the exponents positive. So I have y to the 5th over x to the 10th. We have about 10 minutes remaining. So even tomorrow for this class, I'm going to have the lab here. We'll be able to work in class on the Khan Academy assignment. But we'll just take this out because I know you're dying to get home and work on this today. You don't want to wait till tomorrow. I have an assortment of all the different exercises that were assigned. And we can just work on some of those. We'll get through as many as we can in 10 minutes. I just wanted to point these out. I'm not gonna do any of these, but I just wanted to show you. Like you have a couple that are like this.
I can't see it.
That says cube root of 1,000. That's pure calculator. The reason why I even put these on here is just to make sure you know how to use the calculator. You know, but this one cube root, that's all calculator. I think there's one more like that. Could have sworn I saw another one that was all. Maybe it is only one of those. What's the cube root of 1,000?
10.
10. Yeah. Whether you have a cube root button or your root button.
I didn't get that.
And that's why I put this on, because we gotta make sure we do. You're putting 3 times square root. You're not hitting a cube root. You're hitting a square root. Now you see how that comes in next. Probably the ones that are most important for the test are this little group in the middle. The ones that you can pretty much expect won't be on the test, but are just there to challenge and annoy you. I can't. I'll write it bigger, but towards the end, you see these that have challenge on it. Like this one actually could be something on the test, because it just deals with properties of exponents. But typically on Khan Academy, the ones that say the word challenge, those tend to go a little bit above and beyond. But here, this is something you should have to know. Rewrite this expression as it says 4. Rewrite it as 4 to some power. And this says actually 4 to the 6 times 4 to the negative 8. Clear? Because those bases are the same, what are you allowed to do with the powers? Tab, there's a strict no dabbing policy in here, class. No dabbing. Yes. You can add them, yeah. Now, when you add a negative, that's the same as subtracting. So this would be 4 to the 6 plus negative 8, which is 4 minus 8. What is 6 minus 8?
4 minus 2.
6 minus 8 is negative 2. Yeah, so we get 4 to the negative 2. Is that in simplest form? No, it's not. Why? Because I have a negative exponent. But in this case, they gave me directions that supersede just simplifying. Yes, I was told to simplify, which is what I started to do, but they gave me directions beyond that, which says write it in this form. Like leave it as an exponential. So even though I'm not supposed to leave negative exponents, I'm going to do that here. 4 power negative 2.
But if they wanted you to like simplify.
If they wanted me to continue simplifying, then what I would do is, because it's negative, I have to drop it. So this would be 1 over 4 squared. And then what's 4 squared? 1 over 16. Well, we got to follow directions. 1 over, it was 4 to the negative 2, because they told me to leave it 4 to the negative 2. Okay, rewrite this expression in radical form. These should be a gimme. Wow, I can't even read that. I think that says 1 over 6. If not, then I'll find out the hard way. This says k to the 1 over 6, but I don't know, I can't read that 6 really well.
It looked like
A 9?
Wow.
Let me see on my other screen. Maybe on my other screen I can see it better. No, this is the wrong one. It is a 9. Wow. Okay, your eyes are better than mine. It is a 9. Okay. It is 1 over 9. And all they want me to do is rewrite it in radical form. it would be now the denominator becomes the index, so it would be a 9th root of k to the first, which is just k. Last period, I just had this as a question. Mr. Romero was trying to do the assignment, but it wouldn't let me put in any root other than a square. It wouldn't let me put in an index. So hopefully that person goes home and watches the video tonight. Because as of now, I'll be putting this video up. How would I put in a 9th root? Well, first I would hit the 9, and if we know how to use the calculator based on what we know from the calculator. Well, actually, wow, no, they don't have it.
The bottom left.
You take the one with the 3.
The one with the 3, you think?
Yeah.
But that looks like a cube root.
But you have to change it.
No. Oh, yeah, okay, good. That's actually a good point. Very good. Okay, so do it that way. Hit a cube root, but then go up to the 3. Very good. And change that to a 9. That makes sense. Yeah, you wouldn't be able to do that with a square root. Did everybody see that? So it's documented. It's on video. Change that to a 9, then a k. Yay. Okay, here's another one. Rewrite in exponential form. These would be like, these are the most applicable to what could show up on a test. You won't have a ton of these because, again, what did I tell you yesterday? What are going to show up the most on the test? What is the highest volume going to be like on the test? What have you had quizzes on so far? Polynomials, radicals. Now, all the radicals, yes, the square root I would assume is going to be the most common one. You could assume that it would be the most common, but polynomials and radicals. But if you were to get something like with these sprinkled in, it'll be something like this. So let's get this and rewrite this as b to a power. What power would it be here? 4 over 3. Good. B to the 4 over 3. That's not simplest form, but that's what they're asking us to do, is write it in exponential. B power. I did this thing last period. You got 4 minutes left. B power 4. Oh, come on. So maybe see them now. There it is. B power 4 over 3. Nope. Look, this brings up another thing if you're still paying attention. When I have to put a fraction as an exponent, use a parentheses. Or I guess maybe I can hit this too and see if it'll let me hit this too. Yeah, maybe there you go. That's maybe easier. 4 down 3.
Correct. Oh.
Did I read it wrong? Is that not a 3?
It's probably.
Yeah, maybe that's a 9 again. Maybe that's a 9 and I just can't see it. Let's try with a 9.
So the 3.
Okay, there it is. So just rewrite this. It was a 9. I can't see it on the board. That's a 9. All right, go ahead and